Good afternoon, everyone. For today, pag-uusapan naman natin is all about isobaric process or constant pressure process. So, as I said, last lesson, anim na formulas lang yung kailangan natin kabisaduhin para ma-derive natin lahat ng formula sa isang process. Like ito, heat. Heat is equal to integral of TDS limits from 1 to 2. Or pwede rin siyang in terms of heat is equal to change in internal energy plus work non-flow. Pag sinabi namang work non-flow, integral lang siya ng PDV limits from 1 to 2. Then always, internal energy is equal to mcv delta T. Enthalpy is mcp delta T. And kapag sinabi namang work steady flow, negative integral naman siya ng VTP. Limits from 1 to 2. Kabaliktaran lang ng work non-flow. So, itong anim lang yung kailangan natin para ma-derive lahat ng formula sa isobaric process. Now, pag sinabi natin constant pressure process, P is equal to C or N is equal to 0. Di ba we have, may formula tayo nung last meeting na P V raised to N is equal to C. Since yung N mo is equal to 0, so magiging V raised to 0 yan. Or any number raised to 0 is equal to 1. Kaya pressure is equal to constant. Ayan. Importante yan kasi tinatanong yan sa elements ng board exam. At importanteng concept din sa isobaric process. So kapag sinabi nating isobaric process, tinatawag siyang constant pressure or isopiastic. Kapag tinanong, what is the other term for isobaric process? Ang sagot, isopiastic. Isopiastic. Okay. Now, let's proceed na dun sa graph nung ating PV diagram nung ating isobaric process, the PV diagram and the TS diagram. So, ganun pa rin, P natin yung nasa y-axis, V natin yung nasa x-axis. So, process 1 to 2. So, mula sa maliit na volume, papalaking volume. Constant pressure yan. So, etong area na nabuo sa loob, ang tawag yan ay work non-flow. Kasi ano nga ulit yung work non-flow? Work under the PV diagram. Then, TS diagram naman, ang mapo-form dyan na area ay heat. So, from process 1 to 2. So, yan lang yan. So, ganyan lang mag-analyze ng graph. Lumampas. Ayan. So, yung area niyan, area nito, work non-flow. Yung area naman nito ay heat. Okay? Ayan. Next. Now, dun ulit tayo sa PBT relationship. Gamitin natin yung combined gas law. Since constant volume, makakancel lang dito yung since constant pressure, makakancel lang dito yung pressure, therefore, matitira ay V2 over V1, kinross multiply lang natin, V2 over, cross multiply yung V1, V1 is equal to, cross multiply natin yung T2, T2 over T1. So, meron na tayo agad isang formula. Now, for the work non-flow, since meron tayong area kanina, pinakita ko nga dun sa diagram, therefore, meron tayong value ng work non-flow kapag isobaric process. So, ano nga ulit yung formula niya? Work non-flow is equal to integral of PdV limits from 1 to 2. Okay. Labas natin yung P. Since constant yan, lahat ng constant sa integral nilalabas. So, P, integral of dV limits from 1 to 2. But what is the integral of dV? ang integral ng dv ay v, then lagay natin yung limits from 1 to 2. Then substitute natin yung limits dito sa v natin. Therefore, work non-flow is equal to p v2 minus v1, upper limit minus the lower limit. So meron na agad tayong pangalawang formula. Okay? Dali lang, no? Basta alam mo yung flow or paano nakuha or na-derive yung formula. The more na alam mo paano siya na-derive, the more na madali mo siyang makakabisa or mamememorize. But since PB is equal to MRT, pwede natin i-write yung P as MRT over P. Kinross multiply lang natin yung P or dinivide natin both sides by 1 over P. Substitute natin ngayon. So in terms of V1, kung V1 yan, V1 is equal to M R T1 P1. Diba? Kung V2 naman siya, V2 is equal to M R T2 over P2. Then substitute natin. So V2 natin, MRT2 over P2, substitute natin dito sa V2. Kaya siya naging ganyan. V1 naman natin, MRT1 over P1. Meron ba tayong common terms? Meron. Ano yung common terms natin? MR. So ilabas natin yung MR. Ang kalalabasan yan, MRT, tama? T2 minus T1. Paano naging T2 minus T1? Kasi nga, constant pressure tayo. Yung pressure natin dito at saka sa denominator, makakancel lang. Diba? Kasi P is equal to P1 is equal to P2. So, from this formula, may madiderive pa pala tayong bago. So, ginagamit to kapag ang given natin sa problem ay in terms of temperature lang. Kasi meron sinasabi, constant pressure process, pero ang given sa problem is dalawang temperature. Hindi mo naman to pwedeng gamitin kasi wala namang temperature dyan. Kaya dalawa yung formula natin. Pwedeng ito, work non-flow is equal to PV2 minus P1, or pwedeng ito, work non-flow is equal to MRT2 minus P1. Okay, clear naman? Next. In terms of heat naman, gamitin natin yung formula Q is equal to internal energy plus work non-flow. But internal energy plus work non-flow, equivalent din yan sa enthalpy. Kasi by definition, enthalpy is a combination energy. Anong combination energy niya? Internal energy plus work non-flow. So, therefore, Q is equal to delta H, or ang delta H natin laging MCP delta. Now, doon naman tayo sa internal energy. Pag sinabi naman internal energy, lagi yan mCV delta T. So, kahit anong process, yan palagi ang ating formula. Enthalpy, mCP delta T. Entropy naman. So, paano natin madiderive si entropy? So, since heat is equal to change in enthalpy, therefore, gamitin natin yung formula ng heat in terms of integral. Formula ng heat natin, dun sa 6, ito yan, di ba? Heat is equal to integral of TdS limits from 1 to 2. Anong formula ng delta H natin? Integral of mCp delta T limits from 1 to 2. Okay? So, multiply natin both side by 1 over T. Para matira na lang dito, integral of 1 to 2 ds. Dito naman malalagyan siya ng over T. Integral of mCp delta T over T limits from 1 to 2. Okay. Tapos, since ang derivative natin dito ay T, ilabas natin yung constant, which is mCp. Kaya magiging integral of ds limits from 1 to 2 is equal to mCp, integral of tt over t limits from 1 to 2. But ano to? Integral of ds, pwede mo siyang i-write as delta S, di ba? yung limits, integral of ds, limits from 1 to 2 is equal to delta. So, i-write natin. Okay? Then, kunin natin yung integral nito. The integral of dt over t is equal to ln t limits from 1 to 2. So, substitute natin, delta s is equal to, copy lang natin, delta s, copy yung m, copy yung cp, ln, t2 minus ln t1. But meron tayong law of logarithm kung saan ln a minus ln b, ito yan, ln a, ito yung b mo, is equal to ln a over b. So, pwede mo siyang gawing fraction. Therefore, delta s natin is mcp ln t2 over t1. But what is t2 over t1? Kanina sa pinakaunang formula natin, di ba? P1 V1 over T1 is equal to P2 V2 over T2. Na-derive natin yung T2 over T1 is equal to P2 over V1. Kaya pwede mo siyang palitan in terms of volume. So, kapag given yung temperature, ito yung gagamitin mo. Kapag given yung dalawang volume, ito yung gagamitin mo. Okay? So, madali lang, no? You don't need to memorize. Now, work steady flow is the area beyond PV plane. Okay? May area ba tayo beyond PV plane? Di ba wala naman? At pag titingnan natin yung formula, dP is equal to 0. Kasi wala naman tayong change in pressure kasi constant. Oh, sorry. Bakit volume yan? Pressure dapat. Square. Tama, tama. Pressure. Yan. Okay? So, dP natin is equal to 0 kasi nung meron, constant pressure tayo. Constant pressure, ibig sabihin walang nagbago sa pressure. Therefore, dP mo is equal to 0. Kung 0 yan, any number multiplied by 0 is equal to 0. Therefore, work steady flow mo is equal to 0. Mas madali itong isobaric kasi unlike sa isometric, meron siyang tinatawag na reversible at irreversible. Dito, walang ganon. Kaya automatic work steady flow is equal to 0. Okay? Now we're done with the formula. Ano naman yung example of constant pressure? So kapag sinabi sa problem, minsan kasi 'di ba nakikita nyo sa problem, minsan sinasabi constant pressure, constant temperature, minsan naman hindi nilalagay. So ito yung mga natin, kodigo para malaman natin kung constant pressure siya. So kapag may binanggit na steam generator sa problem, automatic constant pressure yan. Or may binanggit na economizer, steam boiler, superheated. Yan. Yan yung mga keyword natin. Okay? Kasi yung iba, sasabihin typo yung problem, yung pala, meron talaga siyang keyword na kailangan tandaan para mas solve mo yung problem. So, eto, pag lumabas yung mga ganyan, constant pressure yan. Pag may nabasa rin kayong condenser, constant pressure yan. Air preheater, ayan. Constant pressure yan. Or, any shell and tube heat exchanger. Pag may nabasa kayong heat exchanger, ayan. Constant pressure automatic. Okay? Pag sa exam, ganyan yan Pag sinabi kong air preheater, constant pressure yun. Hindi mo pwedeng sabihin sa akin, sir, hindi nakalagay kung anong process siya. You have to analyze and look for the coding na nilagay ko. Okay? Sa volume, meron din akong nilagay. Okay, so start na tayo sa problem. Problem number 1. A certain gas with Cp is equal to 0.529 BTU per pound mass, degree Rankine, and R is equal to 96.2 foot-pounds per pound mass degree Rankine expand from 5 cubic feet and 80 degrees Fahrenheit to 15 cubic feet. While the pressure remain constant at 15.5 psi, compute for the temperature to change in enthalpy, change in internal energy, change in entropy, and for an internally reversible non-flow process, what is the work? Okay? So, given natin, paano na paano natin nasabi na pressure is equal to constant? Kasi sinabi sa problem, pressure remains constant. Okay. So, isayin natin yung ating mga given. So, binigay CP, 0.529 BTU per pound mass degree Rankine. Binigay din yung R, 96.2 foot-pounds per pound mass degree Rankine. Since constant pressure, therefore P1 is equal to P2 at 15.5 PSI absolute. Meron tayong V1, 5 cubic feet. Ito yan. And meron tayong T1 which is 80 degrees Fahrenheit. Gawin lang nating absolute. So magiging 540 degree lang tayo. Sorry. Okay. Excuse me. We have V2 which is 15 cubic feet. So ang tinatanong, malinaw na malinaw, T2, delta H, delta U, delta S, and work non-flow. So for the solution, ito ay isang direct sum lang naman na problem. Igagamitin natin ang formula na ginamit, na dinerive natin kanina. Now, solving for T2, we have T2 over T1 is equal to V2 over V1. I-cross multiply natin yung T1 sa kabilang equation. So, matitira yan T2 is equal to T1. Copy mo yung T2 over V1. Meron kang T1, meron. Meron kang V2, meron. Then, meron kang V1. So, direct sub lang. So, T2 is equal to 540 degree Rankine. Okay. Times 15 cubic feet over 5 cubic feet. So, cancel lang yung cubic feet. Therefore, T2 mo is equal to 1,620 degree Rankine. So, since ang capital T yan na yung sagot. Hindi mo na kailangan i-minus 460. Okay, next. So, delta H, lagi yung MCP delta T. Meron ba tayong mass? Wala, no? So, kailangan kunin pala natin yung mass. Meron tayong CP. Meron. Delta T, meron. Kasi meron ka ng dito. So, solving for mass, ang gagamitin natin, PB is equal to MRT. Then, cross-multiply natin, ito dito, magiging P1B1 over RT1. Substitute, meron tayong P1, which is 15.5 PSI absolute or pound force per inch squared. Kailangan natin feet squared, so convert natin 144 inch squared is equal to 1 feet squared. V1 natin is 5 cubic feet. R natin is 96.2 foot-pounds per pound mass degree Rankine. Then T1 natin is 540 degree Rankine. Okay? By cancellation of units, cancel to, inch squared cancel, feet squared, isa na lang to, then cancel yung feet, cancel yung degree Rankine. So, matitira dyan is pound mass, which is 0.2148 pound mass. Now, hindi yan yung hinahanap natin. Kailangan natin ay yung enthalpy. So, substituting the value, enthalpy is equal to 0.2148 pound mass. CP natin ay 0.529 BTU per pound mass degree Rankine. Then, delta T natin is T2, which is 1620 minus 540 degree Rankine. So, cancellation of units, pound mass. Therefore, enthalpy natin is 122.720 BTU. Okay. Next. So, change in internal energy. Always ang formula mcv delta T. So, hindi naman given yung CP. CV, solve natin. CV is equal to CP minus R. Given yung CP, given yung R. Yung CP natin kanina, 0.529 BTU per pound mass degree Rankine, minus R. So, since yung R natin is in terms of foot-pounds per pound mass degree Rankine, convert natin. So, 778 foot-pounds is equal to 1 BTU. So, cancel to. Matitira dyan, tataas yung BTU, BTU per pound mass degree Rankine. So, same units na sila. Input nyo sa calcu, CV is equal to 0.4053 BTU per pound mass degree Rankine. So, meron ka ng CV, meron ka ng mass, meron ka ng delta T, direct sub na lang. Therefore, delta U is equal to 0.2148 pound mass times CV natin, yun yung nakuha natin, 0.4053 BTU per pound mass degree Rankine. Then, temperature difference, 1620 minus 540 degree Rankine. So, cancel yung degree Rankine, cancel yung pound mass. Titira dyan, 94.023 BTU. Now, solving for entropy, we have a formula delta S is equal to mCpL and T2 over T1. Meron kang mass, meron kang Cp, meron kang T2, meron kang T1, so direct substitution lang. So, delta S is equal to mass natin, 0.2148 pound mass. Cp natin is 0.529 BTU per pound mass degree Rankine. Then, Ln natin is 1620 over 540. So, since parehas siyang degree Rankine, makakancel lang yan. Makakancel yung pound mass. So, dapat yung entropy mo in terms of BTU per degree Rankine. So, input nyo sa calcu, delta S is equal to 0.1248 BTU per degree Rankine. Now, solving for the work non-flow, we have a formula of work non-flow is equal to P V2 minus P1. Meron ba tayong V2? Meron din tayong V1 at the same time given yung pressure which is constant. Pressure natin is 15.5 pound force per inch squared. So, kailangan natin na in terms of feet squared. So, convert natin. 144 inch squared is equal to 1 feet squared. V2 natin is 15. V1 natin is 5. Unit niya is cubic feet. Then, itong sa ilalim is just a conversion. 1 BTU is equal to 778 foot-pounds. So, cancellation of units. Cancel to. Cancel to. Cancel. Magiging isa na lang. Then, cancel. Kasi meron dito sa baba. Therefore, yung unit mo dapat in terms of BTU. So, input nyo sa calcu, work non-flow is equal to 28.689 BTU. Okay. So, direct sub lang kapag kabisado mo yung formula. So, number 2, a perfect gas has a value of R is equal to 319.2 joules per kilogram Kelvin and K is equal to 1.26. If 120 kilojoules are added to 2.27 kilogram of this gas at constant pressure when the initial temperature is 32.2 degrees Celsius, find the temperature 2, delta H, delta U, and the work for non-flow process. So, sinabi dyan is constant pressure, automatic P is equal to C. So, kunin natin yung given. R natin binigay 319.2 joules per kilogram Kelvin or convert natin in terms of kilojoules, 0.3192 kilojoules per kilogram Kelvin. Given din yung specific heat ratio which is 1.26. So, given din yung heat which is 120, positive yan kasi added. Meron din tayong mass of 2.27 kilogram. and temperature 1, kasi initial temperature, which is 32.2 degrees Celsius or 305.2 Kelvin. Now, ano yung hinahanap? So, find, malinaw naman yung T2, delta H, delta U, and the work non-flow. So, solution. Madali lang tong isobaric kasi almost ano lang naman. Direct sa. Kailangan master mo yung formula. So, for the solution, solve muna natin si T2. Anong formula? Since given yung heat natin, diyan natin kukunin si T2. Heat is equal to mCp T2 minus T1. Meron tayong heat, meron tayong mass, wala nga lang tayong Cp pero meron tayong T1. So, let's solve for Cp. Saan natin makukuha yung Cp? Meron tayong K, meron tayong R. So, gamitin natin yung formula natin sa chapter 3 where Cp is equal to Kr over K minus 1. Okay? Anong K natin? 1.26. Anong R natin? 0.3192 kilojoules per kilogram Kelvin over 1.26, which is yun yung K minus 1. So, walang cancellation of units dito kasi wala namang units sa baba. So, kung anong units mo dito, yun dapat yung units ng CP mo. Therefore, pag in-input natin sa calculus, CP is equal to 1.5469 kilojoules per kilogram Kelvin. So, since meron ka ng CP, makukuha na natin si T2 by the process of shape solve. So, from equation 1, we have, substitute natin yung heat, which is 120 kg. Mass natin, 2.27 kg. Ito yan. CP natin, yung kakakuha lang, 1.5469 kilojoules per kilogram Kelvin. Then, T2 yung nawawala. So, as is, minus T1, 305.2 Kelvin. Okay. So, cancel dito yung kilogram. Cancel dito yung kilojoules. Matitira mong units is Kelvin. Therefore, T2 mo is equal to 339.374 Kelvin. So, since a big letter T yan, yan na as is yung sagot. Solving for delta H, always ang formula niya, MCP, delta T. Meron kang mass, meron kang CP, meron kang delta T, so direct sum. Mass natin, 2.27, CP is 1.5469. Delta T natin is T2, 339.374 minus T1, 305.2 Kelvin. By cancellation of units, cancel yung kilogram, Kelvin. Dapat ang units mo dyan ay in terms of kilojoules. Therefore, delta H mo is 120 kilojoules. Okay? Solving for internal energy, always yan mCV delta. Meron ba tayong CV? Wala. So, yung CP natin, pwede natin siyang i-write as CP minus R. Kasi di ba CP is equal to, CP yung pinakamalaki, di ba? As I said dun sa chapter 3 natin. CB plus R. So, ilipat natin yung R sa kabila, CV is equal to CP minus R. So, yung CP mo, substitute mo lang to, kaya siya naging ganyan. So, meron kang mass, meron kang CP, meron kang R, meron kang delta T, direct sum. So, delta U is equal to, mass natin 2.27, CP natin 1.5469, R natin is 0.3192, delta T natin is 339.374 minus 365.2. Okay? 305 yan dapat. Kasi magne-negative yung mga. 305 yung ating temperature. Okay? Therefore, delta U is equal to 95.239 kilojoules. Then last, for the work non-flow, sabi ko nga pag isobaric, work non-flow and work steady flow, as is kung ano yung formula natin, hindi siya nababago. Work non-flow is equal to MRT2 minus T1. So, Kanina yung ginamit natin, work non-flow is equal to P V2 minus V1. But since yung sabi ko nga given natin dito ay in terms of temperature, dalawang temperature yung given natin, para hindi na tayo maga, para hindi na natin itong kuning dalawa, ito na lang yung formula na gamitin natin. Yung dinerive natin kanina. Meron kang mass, meron kang R, meron kang T2 minus T1. So direct sub, work non-flow is equal to 2.27 times yung R natin, 0.3192. T2 natin, 339.374. Then T1 natin ay 305.2. So unit-wise, dapat ang units niyan ay kilojoules. So work non-flow is equal to 24.762 kilojoules. So that's all for today. Stay safe and thank you.